Today, we are talking about a massive shift happening in artificial intelligence. Seriously, a tectonic shift. We're moving away from these giant centralized AI brains in the cloud to something radically smaller, way faster, and actually woven into the world around us. So yeah, let's dive into this quiet revolution that's happening right under our noses. Not too long ago, if you were talking about AI agents, you were pretty much just talking about one thing, OpenClaw. It didn't just show up, it was an absolute explosion. It completely captured everyone's imagination. The promise was just intoxicating, right? A single, all-powerful AI to handle our entire digital lives. But you know how these stories go. Beneath that incredible, shiny surface, a huge flaw was hiding in plain sight. This agent that basically took over the world was built on a foundation that was, well, fundamentally broken. So what on earth went wrong? To really get the scale of the fall, you first have to understand the scale of its rise. OpenClaw became the fastest growing project in GitHub history. We're talking over 200,000 stars in just 84 days. That's just unheard of. It was a total phenomenon. And then, boom, the other shoe dropped. A security audit came out and found 512 vulnerabilities. 8 of them were critical. Now, for an agent that's designed to have deep access to your system, this wasn't just a red flag. This was a full-blown 5-alarm fire. The real root of the problem was its architecture. OpenClaw was a classic monolith, basically one giant tangled block of code. Now, that approach can feel powerful when you're starting out, but man, it comes with some enormous baggage. And this is where that architectural nightmare gets really, really real. We're talking over a gigabyte of RAM just to sit there doing nothing. An agonizing 500-second startup time, you could literally go make a coffee and come back. And worse, it ran with full system permissions, which created this massive attack surface. But here's the kicker. It was so vulnerable to prompt injection that you could trick it into deleting your entire production database by accident. Yeah. So, this crisis, it forced a massive paradigm shift. The whole industry pivoted. We moved away from languages like TypeScript to high-performance systems languages, Go, Rust, and Zig. We went from needing gigabytes of RAM to just megabytes, from minutes of startup time to milliseconds. And this right here, this just brilliantly illustrates the economic shift, from needing a $600 machine to running on $5 hardware. And this new era, it gave rise to a whole new breed of AI agent, the microarchitectures. These are the new challengers, built from the ground up to be lean, fast, and incredibly secure. And this table, well, it tells the whole story, doesn't it? Just look at those numbers for Null Claw. I mean, that's the most extreme example. We're talking about 1 megabyte of RAM usage and a binary size of 678 kilobytes. That is not an improvement. That's a complete redefinition of what is even possible. Okay, so first up is Pico Claw, written in Go. It's the adaptable pioneer, perfect for bringing old hardware back to life. But its most fascinating feature? 95% of its own code was generated by an AI. Think about that. It's a self-bootstrapping process. It literally helped build itself. It even learns from experience using something called a gene evolution protocol, which is just a fancy way of saying it remembers what works and it gets better over time. Next up, we have Zero Claw. You should think of this one as the corporate fortress. It's built in Rust, and its entire reason for being is security and reliability. Every little piece is modular, and every action it takes runs in an isolated sandbox by default. So for things like banking, CI/CD pipelines, or any place handling sensitive data, this is the new gold standard. And finally, there's Null Claw, the minimalist extremist. This thing is just a feat of pure engineering, an entire, fully featured AI agent in a file that's smaller than most photos you have on your phone. It's written in Zig, so it has absolutely zero runtime overhead. It uses this really clever V-table architecture. Think of it as a super efficient plug-and-play system that lets it support over 50 different AI providers, all while running on hardware that costs less than a cup of coffee. So, here's the crucial point. This incredible efficiency isn't just about saving memory. It's about unleashing AI from the data center, from the browser, and letting it step out into the physical world. Because these agents are so tiny, they can directly control hardware through low-level interfaces like GPI. You know, those little general-purpose pins on a circuit board that let software talk to hardware. This means they can read data from physical sensors, analyze camera feeds, and control motors, all in real time. This is the birth of truly smart IoT and autonomous factories. And this also signals the end of the God agent, that single monolithic entity that tries to do everything. The future is the swarm. Just imagine a fleet of these tiny, specialized agents all working together. One agent writes code, another one tests it, a third one deploys it. This dramatically reduces the risk of a single point of failure and just makes the whole system more resilient. And critically, this is all happening locally. By running on the device and integrating with local models using tools like Ollama, which lets you run powerful AI models on your own machine, your data never has to leave your control. For fields like medicine or law, where privacy is absolutely everything, this is a total game changer. And universal communication standard means all these different little agents can work together seamlessly. Now, this isn't just a technological revolution, it is an economic one. Let's really unpack the return on investment for this $5 AI. This slide just says it all, doesn't it? The cost of hardware required to run a capable AI agent has completely collapsed. We went from a $599 Mac Mini for OpenClaw to a $5 board for Null Claw. That is a cost reduction of over 99%. For any business, the advantages are just undeniable. You get a dramatic reduction in your server costs. You can run 50% more agents on the exact same hardware. You eliminate API latency, so you get instant responses. And best of all, you get security by design, not as some panicked add-on later. So, where does all this lead? Well, the conclusion is pretty inescapable. The future of AI is not in the cloud. It's on the edge. This right here is the key takeaway. Intelligence is becoming decentralized, it's becoming ambient, and it's being embedded into the devices all around us. AI is finally leaving its digital cage and becoming a true part of our physical reality. The era of those big, clunky cloud monoliths is dead. The future belongs to microarchitectures, operating at the speed of thought. You see, this isn't just some technical shift. It's a fundamental transfer of power. Power into the hands of creators. Into your hands. So the question I want to leave you with is this. Now that a truly autonomous AI agent can run on a $5 chip, what will you build?